Section: Introduction. In this section, we discuss how Retrieval-Augmented Generation Systems, RAG, work. RAG combines a generative language model with a non-parametric data store, which often outperforms larger purely parametric models in language tasks. RAG systems are great for handling tasks that require a lot of knowledge and dealing with less common knowledge. They also allow us to trace back generated text to its sources. One cool thing about RAG is that it can update its knowledge without needing to be completely retrained. This means the model can learn from new information found in retrieved documents. When using RAG, language models can either rely on what they learned during training or on the new information from retrieved documents. If these two sources conflict, it's called a knowledge conflict or context memory conflict. A knowledge update occurs when the model changes its original answer based on new conflicting information. There are three main situations where knowledge conflicts happen with RAG systems. First, training a large language model takes a long time, and during that time, the information it learned may become outdated. Second, most users don't start from scratch when training models. Instead, they adapt pre-trained models to new tasks. These new tasks often require different knowledge than what the model was originally trained on. Third, language models are trained on huge amounts of text that may contain incorrect information. Failing to update the model with the right information poses a risk to the user. This is why we want to understand how knowledge updating works when there's a conflict between what the model already knows and new information. Our study focuses on how language models update their knowledge when faced with conflicting information. Previous studies mostly looked at artificial conflicts, where made-up documents contradicted the model's correct answers. We, on the other hand, study how models update their incorrect knowledge using real factual documents. This reflects how RAG is used to improve the limited knowledge of language models. Our approach differs from previous work in that we find knowledge updates fail less often in real scenarios than previously reported. We also identify a bias where models stick to their wrong initial knowledge instead of using new information from the context. This bias negatively affects the model's ability to understand what it reads. We confirm this bias through experiments across different datasets and model sizes. Our study adds to the existing research on building reliable language models through retrieval-augmented generation. RAG combines a retrieval system with a pre-trained generative model and is widely used for knowledge-intensive tasks in natural language processing. By using a generative language model, RAG offers more flexibility than older methods, while retrieving information from a non-parametric source helps overcome issues with fully parametric models. RAG improves performance even with smaller models, allows tracking text sources, and supports updating knowledge when needed. However, not all knowledge updates in RAG are successful, and we aim to understand why. Section Summary. In this section, we explore how Retrieval-Augmented Generation Systems, RAG, update their knowledge when faced with conflicts between parametric and contextual information. RAG systems combine generative language models with non-parametric data stores, allowing for knowledge updates without costly retraining. We investigate cases where knowledge updates fail due to a parametric bias, showing that models may not utilize new contextual knowledge if it contradicts their existing parametric answers, impacting reading comprehension abilities. Section: Experimental Design. In this section, we aim to understand how often language models, LLMs, update their knowledge when faced with real factual documents that contradict their incorrect parametric answers. Previous studies only looked at knowledge updating behavior with artificial documents that contradicted correct model knowledge. We introduced a new framework to study knowledge updating behaviors in LLMs and then explained the problem setup. Our empirical analysis details are provided next. We created an experimental setup that mimics real-world scenarios and allows us to observe how LLMs update their knowledge. We focused on a question-answering task and identified a data subset where parametric knowledge falls short. This subset belongs to a new domain, for which we adjusted our model using a specific approach. We then tested the model on this subset with retrieved documents that always contain correct answers conflicting with the model's incorrect parametric knowledge. Our experiment involved 3 stages of sample categorization. In the first stage, we tested the model for its parametric knowledge without context. This helped us identify conflicts with contextual information for later steps. In the second stage, we filtered out examples without conflicts by removing correct answers and answers that did not contradict the context. The third stage involved studying knowledge updating behavior under conflicts by running the model with context. The answers were categorized as correct update, retain parametric, or incorrect update based on the model's response to the context. We used specific notation to define knowledge updates and correct knowledge updates. In the third stage, we categorized examples into correct update, retain parametric, and incorrect update subsets. We also explored how the initial parametric answer influenced context reading ability and the impact of in-context demonstrations on knowledge updates. Section Summary. In this section, we aim to understand how often language models, LLMs, update their knowledge when faced with real factual documents that contradict their incorrect parametric answers. We introduce a new experimental framework that mimics real-world scenarios and focus on the question-answering task to study LLM knowledge updating behaviors. By categorizing samples into closed-book answer gathering, filtering out no-conflict examples, and open-book QA under knowledge conflict, we observe how LLMs update their knowledge when presented with conflicting information in real contextual documents. Section: Experimental Details. In this section, we examine knowledge updates across various open-book QA datasets like Natural Questions, NQ, Squad, News QA, Trivia QA, Search QA, and Hotpot QA. We use specific versions of these datasets from the 2019 MRQA shared task. We focus on studying the Llama 2 family models, particularly the 7B and 70B models. Additionally, we look into Mistral 7B and Mixtral 8x7B models. To evaluate these models, we use the BERT matching (BEM) metric instead of exact match (M) to assess answer correctness more accurately. We create a dataset with realistic knowledge conflicts by gathering closed-book answers from a language model and filtering out conflicting information. This dataset is used to analyze how language models update their knowledge when faced with conflicting information. By studying the behavior of LLMs on this dataset, we observe that they tend to update their knowledge when provided with factual contexts. However, we also investigate cases where knowledge updates do not occur, particularly focusing on instances where incorrect answers persist even after presenting relevant documents. Our analysis reveals that in cases where knowledge updates fail, the incorrect parametric answer often appears in the retrieved document. This observation is consistent across different datasets and models, suggesting that the presence of incorrect parametric answers in the context may lead to knowledge update failures. Section Summary. In this section, we examine knowledge updates across various open-book QA datasets using Llama 2 family models like Mistral 7B and Mixtral 8x7B. We introduce the BEM metric for evaluating QA models and create a knowledge conflict dataset to study how language models update their knowledge when faced with conflicting information, finding that models tend to update their knowledge when presented with factual contexts but struggle when the incorrect parametric answer appears in the retrieved document. Section: Influence of parametric answer in context on knowledge update failures. In this section, we investigate the impact of parametric knowledge on knowledge update failures. We propose that a form of confirmation bias linked to parametric knowledge could be the main reason behind most knowledge update failures. We aim to determine if the presence of parametric answers in the context increases the chances of a knowledge update failure. We analyze the set of incorrect answers in the open book task to represent failed knowledge updates. We compare different scenarios to see if there is a significant difference. Our analysis reveals a noticeable increase in the likelihood of failure when the parametric answer is present in the context for various models across different datasets. This effect, which we term parametric bias, occurs when the incorrect parametric answer negatively affects the model's ability to understand the context. To gain a deeper understanding of parametric bias, we conduct two intervention experiments. First, we mask the incorrect parametric answer when it appears in the context to observe any changes in the model's behavior. Second, we investigate if adding the parametric answer to the context influences the model to retain it. Our experiments show that masking the parametric answer reduces the model's tendency to retain it, indicating that parametric bias may not be the sole reason for the model's behavior. Additionally, adding the parametric answer to the context increases the likelihood of the model retaining it, supporting the existence of parametric bias. Our findings suggest that parametric factual knowledge can interfere with knowledge updating in language models, affecting their ability to comprehend context accurately and potentially compromising the reliability of RAG systems. While previous studies have shown that language models often retain parametric answers, our research indicates that this is less common in real-world knowledge conflicts. However, the interaction between parametric and contextual knowledge poses challenges in realistic scenarios. Despite high success rates in knowledge updating, the presence of an incorrect parametric answer in the context can increase the likelihood of knowledge update failures. This parametric bias could be a more significant issue in RAG systems dealing with evolving knowledge and complex documents. Our study focuses on identifying and evaluating parametric bias, leaving the development of solutions for future research. We suggest that task adaptation and model scaling may help mitigate this bias, but even the largest language models are still susceptible to it.